বিদিশা, তুই কি জয়েন করবি মিটিংটাতে? না, কারণ ছেলে মেয়েরা একটু পুশ করে আমাদেরকে ম্যাডাম
are these students of bachelor's degree or master's course?
Bachelors, most of them are from bachelor degree, and
Bachelor degree.
10 students are from master.
Master. Okay, fantastic.
Yes.
And have they got any exposure to this weather and climate issues before?
Yes, sir. They are geography students.
Okay.
So they have a minimum idea about weather services and climate.
Wonderful, wonderful.
Some of them are from commerce background.
Commerce.
Yes.
No problem, no problem. So I'll start with the very basics and I'll involve them, and then we will see. I mean, if you have the, I don't know, like, how do I show you the website of IMD and various things? That I'm not. How will we do that? Because that's very important. So will someone from your side be able to open the IMD site, and then I can tell them go to this, show this?
Yes, sir. This is possible.
Okay, great. So once I finish my interactive session and other things, then we go to the website and show them those things, and after that we will take question and answer session.
Okay, sir. Now let us introduce you to our students.
Okay, fine.
Students, it is our great honor to welcome Sri Anand Sharma ji, President of All India IMS, to our internship gathering today. And sir, your presence here is a testament to your tireless efforts in serving the nation and its people. Through your work in weather services, you have been instrumental in spreading awareness about the importance of meteorological information and its impact on our daily lives. And it is fortunate that you are in our Kolkata chapter group, and from where we have found you. We appreciate your commitment to using science for the greater good and your efforts in making complex information accessible to all. And thank you for taking the time to join us today. And we look forward to your insights and thoughts. Please welcome Sri Anand Sharma ji.
Thank you very much. And I'm thankful to your college, your principal, your teacher, and all the students that I'm able to interact with all of you, and it's a great opportunity to, always wanted to be have lecture in the physical mode, because it's better to interact one-on-one. But fine, technology has given us this beautiful mode by which even sitting at Delhi, I can interact with all of you. Okay, wonderful. And geography is such a subject, which encompasses both scientific discipline and social sciences discipline, economics. You mentioned a thing and it's all included in geography. Excellent subject. So I love the geography subject, and I'm very happy Kolkata has lots of, good colleges and even university which offer good courses in geography. When I was in JNU, Delhi, so lots of people from geography backgrounds used to join geography department, CSRD in Delhi. Excellent, and they were the best. I think you also have in some universities Bachelor of Science in Geography, isn't it? Yes. Okay. Now.
Yes.
Yeah. So I think without wasting much time, let us.
Were you in CSRD? By the
No,
way,
I was in School of Environmental Sciences.
Oh,
I had lots of my
yes,
friends
yes.
who were head of the departments of geography department,
Okay,
or
okay.
still they are professors there. They are very good friends of
Okay.
mine.
Okay.
Anyone here with the from CSRD?
Yes, yes. I was
Oh, very good. What's your name?
Pollori Bakchi.
Maybe I don't know. We will interact later
I
after
was
this
a
lecture.
student. I was a student of CSS.
Which year? Which year?
That is in 87.
Oh, you are my
87.
contemporary.
Oh, might be.
Yeah, I was there in 86 to 89 in School of Environmental
Oh,
Sciences. Yeah.
I was there from 87 to 89 or 90.
And wonderful, wonderful. I think maybe after this lecture,
Okay, okay, okay. We will
we'll
have.
discuss more on that.
Okay.
Great, excellent,
Thank you.
excellent. Wonderful. So let us start with the lecture, and I will start with a question to all the this thing, and let me tell you it. I want to make it interactive. So my first question to the participant is: what happens to temperature as we go up in the atmosphere? It increases or decreases?
It
Students
decreases
follow.
6.5 degrees Celsius in heat.
Excellent, excellent. I think you people are all have a concept of lapse rate and it decreases. Wonderful, wonderful. Now, my simple question, next question is why should temperature decrease with height? Normally, what happens is that when you move towards the source of heat, the temperature increases. Here, you are moving towards the sun and temperature is decreasing. So, why temperature decreases as you move up in the atmosphere?
As we are living in the troposphere,
Yeah, yeah.
because with rising altitude in troposphere, the density of the air decreases, and that's why the uh, air get a lower density. That's why the heat is
No,
steady.
good try, but it's not true. Density even decreases in the stratosphere also, and so it's not the answer. But nonetheless, you have a good try. Anybody else?
It increases in the troposphere because air temperature rises due to scattering from Earth's surface, not directly from the sun.
Can you repeat? What did you say?
In troposphere, atmosphere is not gaining temperature directly from sun. It is the scattered temperature from the Earth's surface. So
Okay,
near Earth's surface, it is hotter.
okay. What's your good name?
Sir, Sharoda Mondal.
Arodas. Okay, wonderful. I think you have you need a clap from all the participants. Wonderful. What you are trying to basically say is that heating of the atmosphere is never direct. That means as the solar radiation comes, they don't heat the atmosphere. First, the radiation fall on the Earth's surface. Earth's surface absorbs the radiation, and then it acts as a heat source, and it passes heat to the next layer of the air and to the next. That's what it keeps on losing, and that's why temperature goes on decreasing. That means heating of the atmosphere is indirect, not direct. Is it clear to everyone? Any confusion here? Is it clear? Okay. Anytime if you have any confusion, please do ask. Okay. My next question is what happens to wind speed as you go up in the atmosphere? It increases or decreases?
It increases.
It increases. I think it is Debunjan. Okay, it increases. All of you agree? I hope they are agreeing with this. But why wind speed increases with height? My next question.
Due to lack of frictional force.
Excellent, excellent. Lack of frictional forces. Because at the ground surface, you have buildings, you have mountains, you have trees, so you have all sorts of obstructions which provide friction and wind speed decreases. But as you move up in the atmosphere, no obstruction, very less friction. Whatever friction is there is because of the air molecules. and that's why the wind speed is more. And as you go up maybe even 12, 14 kilometers, you have very strong rivers of wind flowing there. What do we call them? Jet streams. Very strong winds blowing at the something like 120 knots per kilometer, something like that, per hour, sorry. So they're very strong winds at the height of 12 or 14 kilometers. So those we known as jet stream, and they were discovered during Second World War when American planes were flowing from west to east. They could reach faster, and when they were flying back from east to west, they used to encounter lots of friction because of these jet streams, and they used to slow down, and it used to take more time to travel from east to west. That's how the jet streams were discovered during the Second World War. Okay. My next question is, what happens to atmospheric moisture? That means relative humidity as we go up in the atmosphere. It increases or decreases?
Decrease.
Yes.
I think only one person is answering.
অন্যরাও একটু বলো এগুলো পড়েছো তো
Anybody else?
Decreases.
Decreases. Okay. So all of you agree decreases. My next question is why it decreases with altitude? Why moisture decreases with altitude? Yes.
If the lower layer air is hotter, then it will catch more vapor.
Good. That's all fine. What else?
And upper layer more colder than lower layer.
Okay, that's one and the same thing. It's one and the same thing. What else? Okay, I'll ask you the other
Source is
question.
the surface.
Pardon?
Source of vapor is the surface of the earth.
Excellent. The source of moisture is surface, ocean, river, ponds, vegetation. So naturally, where the source is there, you will have more. And as you move away from the source, the moisture goes on decreasing. And you were also right, as the water holding capacity, with increase in temperature, the water holding capacity of the air increases. But when you decrease the temperature, the water holding capacity decreases. I will come to it again next. My next question is, which one is lighter? Which one is lighter, warm air or cold air?
Warm air.
Warm air is lighter. Wonderful. Can anybody of you give me an example from day-to-day life, which proves that warm air is lighter than the cold air?
Water boiling on a pot.
Excellent. Steam going up. So naturally, when we heat or when we burn an incense stick, agarbatti, smoke goes up. So that proves that warm air is lighter than the cold air. Wonderful. Excellent. My next question is, which one is lighter, dry air or moist air?
Moist air is lighter.
Moist air is lighter. Okay. Very nice. Wonderful. Why?
Condensed dry air is heavy than water vapor.
Fine. But question is, what's the basic reason behind it? You said heavy and light, but how will you prove it?
Because that time when the air is full of water vapor, the nitrogen molecules are substituted by the water H2O. So and N2 molecules are higher in weight, and H2O is lower in weight. So
Okay.
or
Okay. I think yes, you are right. You are right. What is the molecular weight of nitrogen gas?
14 grams.
Okay, nitrogen gas because 28. Fine, 92. Okay, 14 into 2, 98. Wonderful, wonderful. And what is the molecular weight of oxygen molecule?
18 grams.
32. 16 into 2, 32. Right. So dry air is basically nitrogen and oxygen. And if you take the average, just to explain it, so it becomes 32 plus 28. If I take average, 60 divided by 30. So if I take a small packet of air, small mass of air from the atmosphere, which has 10 molecules of dry air, its weight will be 30 into 10, 300 grams. Okay? And the molecular weight of water is 18. So if I remove out of these 10 molecules, 3 molecules of dry air and add 3 molecules of water. So now you see how much is the weight. Earlier, when there were 10 molecules of dry air, 30 into 10, 300 grams was the weight. But when I take out 3 molecules of dry air and add 3 molecules of water, it becomes 30 into 7, 210, plus 18 into 3, 54, that is 264. But remember here, as per Avogadro's law, we have to keep the number of molecules constant 10. So from 300, the weight comes down to 264. That means when we add moisture to the air, it becomes lighter. So moist air is lighter than the dry air. Okay? But many people generally think it's good thing, excellent. Again, claps for her. And they think that dry air is, is lighter and moist air is heavier. But if it had moist air been heavier, it will never go up. And for clouds to form and rain to happen, moisture must go from down below to up. Okay, very good. So now I move to the next. See, you all must have observed that when you just have an ordinary tap water in a bottle, nothing appears outside. But if you take out a water bottle from the refrigerator and just keep it outside, what happens? You see outside the bottle something. What is that?
Condensation.
Condensation.
Condensation. Excellent. Small droplets of water. So, what is the source of this moisture?
Atmosphere.
Yeah.
Where from the? From the air. Okay. But when you keep a ordinary bottle, tap water, that thing never happens there, isn't it? It's only when you bring the cold water outside from the refrigerator, then you see those small droplet and that condensation. So again, it proves that warm air can hold more moisture, but cold air cannot hold moisture. So as you put a air conditioner in a room, you see outside from a tube, water is flowing down. The reason being, as you lower the temperature of the room, its water holding capacity decreases and relative humidity goes on increasing. It reaches saturation, and then there is a condensation, and that water precipitates outside what you see from a tube. So this is very clear from here that warm air has more water holding capacity and cold air has less water holding capacity. And during this pre-monsoon, you know that when the heat is too much, temperatures are very high, and you get moisture from the, say, Bay of Bengal, and a lot of heating is there. So that leads to wild thunderstorm in the afternoon, which we sometimes also know called Baisakis in your region and nearby areas. Okay. Now, with this background, I will just repeat what we had discussed. I said, as we go up, temperature goes on decreasing. As we go up, wind speed increases. As we go up, moisture goes on decreasing. Warm air is lighter than the cold air, and moist air is lighter than the dry air. And warm air has more water holding capacity as compared to cold air. With this background, I will try to explain you how rain occurs in the atmosphere. You all know sun is overhead, and it is overhead between Tropic of Cancer and Tropic of Capricorn, isn't it? 23 and a half degree north and 23 and a half degrees south. So these are the latitudes in between where sun is overhead. Although sun doesn't move, but it's relative motion we are talking about. So it's overhead. So when the sun is overhead, you get direct radiation. When the radiation fall on the ground, what happens? It heats up the ground. And the air which is in contact with it, it also gains heat and it becomes hot and light. Therefore, it starts moving up. And at the same time, you also have lots of moisture around near the equator. We have Arabian Sea, we have Indian Ocean, we have Bay of Bengal. So water also evaporates. And as we know, moist air is lighter than the dry air. So in our region, tropical region, due to sun rays falling direct, we have warm and moist air, and warm and moist air being lighter, what happens to it? Because it's light, what happens to it? Yes? Anybody? Hello?
বলো তোমরা কেউ কিছু বলো।
Pardon?
It moves upper layer.
It moves up. Excellent. So this warm and moist air being lighter, it moves up. And when it moves up, what happens to its temperature?
Decreases.
It decreases. And when you have a moist air and its temperature decreases, what happens?
It's condensed.
Condensation takes place. Excellent, excellent. Okay, now my next question. A bunch of flower, you name it as bouquet, isn't it? A group of flowers you call either bunch or bouquet. What do you call a bunch of water droplets?
বলো
Pardon? What do you
Rain.
call? Huh? No,
Rain.
no.
Cloud.
Clouds. Excellent, excellent. Clouds. So, what is happening is that this warm, moist air rising, condensations or droplets form, and this bunch of droplets cloud. And inside the cloud, what is happening? There is a collision and there is a coalescence. बूंदे आपस में टकरा रही हैं और जुड़ जा रही हैं तो बड़ी बन जा रही हैं. And what pulls it down?
The gravity.
Gravity, excellent. Gravity pulls it down. But air currents take it up. Again, there is a collision, there is a coalescence, they become bigger. Again, gravity pulls them down. But again, air currents take it up. And this thing goes off. Finally, when the droplet size is big enough, gravity pulls it down and it falls as rain. Is it clear to everyone how rain? This is simplest mechanism to explain rain formation in the atmosphere. Is it clear to everyone?
Yes, sir.
Or any
Yes, sir.
confusion? No confusion. Okay.
No, sir.
So, very good. So shall I move further? Fine. So my now next question to all of you is, what time of the day you have the maximum temperature of the day? What time of the day you get maximum temperature?
12 p.m. to 3 p.m.
12 p.m. to 3 p.m. Somebody said it's a very, long, he has given 12 to 3. Okay. Anybody else?
2 p.m., sir.
2 p.m. Another question comes to anybody else? No one else wants to try?
3 p.m.
3 p.m. Somebody said 3 p.m. Okay. Now you have to give me a reason why. Why you said that? 12 to 3, somebody said 12 to 3, somebody said 2, somebody said 3. Yes, give me the reason. Why? Yes, I'm waiting for the answer.
Because during 12 p.m. to 3 p.m., the sun provides vertical radiations.
The sun is overhead at 12 o'clock. Yeah. Okay. But remember, sun is at overhead at 12. That is the time when you have the direct radiation. Okay. So then why at 3?
After some time, because of heat consume, then it's hotter.
Comes where? Heat comes where?
Sun.
Pardon? Okay, okay. I'll ask you one more question. At what height these temperatures are generally measured? You have any idea? Have you been? I must have visited the meteorological observatory of at Alipur. You have any idea at what height this temperature and humidity is measured? At what height these
Sea
instruments are kept?
surface.
4 feet.
Pardon?
4 feet.
Sea
Four and a
surface
half feet,
temperature.
right? 4.5 feet, around 4.5 feet in the Stevenson screen. Okay. So what basically is happening is that the direct radiation is at 12 o'clock, but maximum temperatures occur somewhere around 3:30. This we are talking of a day when it is clear sky, no clouds, nothing. So basically, heating takes place maximum at the ground first, and then from ground to 4.5 feet, it takes time. There is a lag. This is called lag. So it takes sort of so much of time. Although 12 o'clock is you get the direct radiation, but temperature registers at around 3:30. Excellent. Okay. Now we move to the next question. What time of the day you get the minimum temperature of the day?
5 a.m.
5 a.m. Okay. Anybody else? Yes. Anybody else?
At 8:30 a.m.
8 a.m. Oh, okay. 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 Anybody else? 5. We have 5. We have 8. Just a minute. We have 8. Yes. Yes. Who else? And you have to give it 3 p.m.
7 a.m.
3 a.m.
6 a.m.
3
5
a.m.
a.m.
5 a.m. Okay, we have 3
5 to
a.m.,
7
5
a.m.
a.m. and 8 a.m. Somebody said 8:30. Vidisha
7
Patra
a.m.
said 8:30. Okay, whosoever has said that, can you give me the reason? Why you said 5? Why you said 8:30? Why you said yes?
So because the earth's surface cools down throughout the night and the air cools.
Okay, okay. Logic is fine. And your answer was at what time? Hello.
I think she said 3 a.m.
Oh, she said 3 a.m. Okay, you mean
I think so.
at 4 a.m.
Because
Radiation is not going back? Okay,
No, sir.
I'll tell you one more thing. See, what happens during daytime? Look, daytime radiation is coming and it's also going back. But more radiation is coming and less is going back. Therefore, temperature rises during the daytime. But once the sun sets, now what happens? Radiation is not coming, but it's going back. Until what time it will keep going back? Hello?
Till sunrise.
Yes, excellent. So till that it will keep on going. So now you can answer at around what time you will have the
5:30.
no, just around sunrise. Okay? Again, why just around sunrise? Because first thing is that radiation is going back till that time. Then in the morning when sun rises up, as we say, and it is at the horizon, it is on the stream, and then it is actually, it's not 12 o'clock, it is at the zenith, top. But during morning, when it rises, it is a very low altitude. So that means it has to travel a long distance to reach you. So by the time the radiation reaches you, most of it is deflected. So it is very feeble. And then when it falls on the ground, ground has the lowest temperature. So there is a mixing of air at ground and 4.5 feet where you record it. There is a mixing of air, and that is the time when minimum temperature is recorded. Okay? And somebody said 8:30. 8:30 we report the temperatures. Okay? Although whenever we have the thermometer, whether it's maximum thermometer or minimum thermometer, they are designed in such a way, anytime when the maximum temperature happens, once it reaches, it stays there. Even when the temperature after that falls, it will stay there. You have to read it and then reset it and keep it for the maximum temperature around 5:30. And at 8:30, you read the minimum temperature, you shake it and reset and again put it for the next day. Is it clear? Any confusion up till this stage? Hello?
Student, respond karo. I think there is no confusion.
No confusion. Excellent. So now we move further. We move further now. So now you must have read in your geography class of different latitudes. You have equator at 0 degree and poles at 90 degree, north and south. And then in between around 30 degree, what do you have?
The Tropic of Cancer and Capricorn in both hemispheres.
Okay, subtropical high pressure belt, basically. At 30 degree, you have low pressure belt at the equator. Okay, then you go to 30 degree, you have subtropical high pressure belt. Then you have
Subpolar low.
subpolar low, and then you have polar low. Very good. Excellent, excellent. So now question comes, why do you have this kind of pressure distribution? What causes that? Why do you have low pressure at the equator?
Due to thermal cause.
Yes, thermal cause. That means sun is overhead.
Students follow.
Okay, sun is overhead. Land is getting heated up. Air in contact with gets heated up. It becomes lighter, so it moves up. When it moves up, there is a vacuum created there. That means now less air is there at that place. So you have a low pressure. Okay, but then what happens to the air which rises up?
Spreads.
After a certain distance, it falls down to the 23.5 high pressure belt.
Yeah, we will say roughly 30. Okay, 23.5 is also fine. From that high to 30 degree. Okay, fine. So in both the hemisphere, it goes and it falls at 30 degree north and 30 degree south. And because at 30 degree north and south, air is subsiding and it is accumulating at these places. So what kind of pressure we expect?
High pressure.
High pressure. That is why these belts are known as high pressure belts. Is it okay? Wonderful. Wonderful. Now, next belt is subpolar low. It's the same mechanism is operating. And then you have polar high.
High.
Why polar high? Because you have very low temperatures and cold air is heavy. So it stays there and it is accumulating there. And moreover, it is heavy because of cold temperature. So you have a high pressure there. So that is how these alternate bands of low, high, low, and high. So, and this also, there is a mechanism for that we know it as 3-cell model of the general circulation of the atmosphere, which explains most of the weather patterns of the globe. So that's very, very important. And now my next question is, winds blow from low pressure to high pressure, or high pressure to low pressure?
High pressure to low pressure.
High pressure to low pressure. So that means they blow from 30 degree north towards equator and similarly 30 degree south to the equator. But what is the direction of the flow? Is it?
In north, all of them. No.
Yeah. In the northern
hemisphere, the air deflects towards its right side. In southern hemisphere, it deflects towards its left side.
Because why it gets reflected?
Due to Coriolis force.
Due to Coriolis force. Excellent, excellent. So Coriolis force is playing a role. So that means instead of coming from north to south from in the northern hemisphere, it comes from northeast direction. And similarly, in the southern direction, it comes from southeast. And these winds from the northern hemisphere, 30-degree north and 30-degree south, they move from northeast, southeast, and meet at equator. What do we call these winds?
Trade winds.
Trade winds. Excellent. So why do we call them trade winds? Because earlier when there were no steam and there was nothing, so we had sail ships. And the sail ships used to make use of these winds to travel and do trade. Okay, fine, wonderful. Great. And this 30 degrees is also known as horse latitude, isn't it?
Yes, sir.
And any idea why do they call it them horse latitudes? No idea. Okay, no problem.
Not exactly, but in past time, some ships threw some horses into the oceans due to their movement easy.
Yeah, very good. Very good. Excellent, excellent. Because this wherever high pressures are there, winds are not, either they're calm or they're not very high speed. So naturally, these ships at that time used to carry lots of horses because in the ocean it was sail ships. Over land, the mode of movement was horses. So naturally, when they used to reach these latitudes, so wind used to be calm, and then ship used to get stalled there. So they thought, some evil forces have started acting on us. That's why the ship is not moving. But it was natural reason because of high pressure belt over there and calm winds. So what they started doing is they used to throw horses. So naturally, ship has become lighter now. So they thought they have sacrificed the animal and now the ship has started moving. So it was a wrong belief. But when later on, research was done, data was collected, then we realized no, it was not some evil forces. It was because of the prevailing weather condition of the region. Because of that, the ship used to get stalled there. Wonderful. And now the place where the winds meet, that means you have northeast trade winds and southeast trade winds meeting at the equator. Where winds meet, what happens? We call convergence. That means northeast and southeast trade winds are meeting at equator. And where there is a convergence, what happens?
Rain.
Ultimate, it may rain and it may not rain. But before that, what happens?
They rises up.
They rises up. Excellent. I think Debanjan is excellent. Wonderful. So these winds, where there is a convergence of winds rise up. And where there is a divergence, there is a subsidence. So this is what you need to understand. Okay? So it's wonderful. Convergence. So at the equator, you have one thing what is happening is convergence. And another thing what is happening is you have sun overhead, heating, that is also making it lighter, and that's how you have upward motion. And for rains to happen, moisture must go up. There should, rain will happen when moisture goes up into the atmosphere. And there are different mechanisms by which the moisture can go up. One is heating, we have discussed. Warm air is lighter, moisture is lighter, so it goes up. Second is convergence. Convergence is another mechanism. And what else? What could be other mechanisms? Anybody has an idea? What other mechanism can take the moisture up in the atmosphere?
Adiabatic processes.
No, this is heating is that only. What else? Yes?
Are you talking about orographic rain?
Excellent. Orography is another one. Orography, wherever there are mountains and like the Western Ghats, winds strike and they rise up. This is called orography effect. You have northeast area, you have horseshoe shape. Bay of Bengal, southerly winds come, hit the mountain, they rise up and give lots of precipitation. Wonderful. Third mechanism. What is the next mechanism which makes the winds go up? Low pressure area.
Cyclonic.
Pardon?
Cyclonic rain.
That's called cyclonic wind. Low pressure. Low pressure means it's a low pressure. When we say there is a low pressure has formed, it means you have the lowest pressure at the center, and you have closed isobar. What is an isobar?
Students, follow.
Equal pressure lines.
Equal pressure line.
Joining.
This is a line joining the areas of equal pressure. So what you do is that you plot the pressure on the chart, and then you draw a line joining the areas of equal pressure. And then you have to follow the wind. You have to follow, suppose wind is coming from west, so you have to follow like this, you have to go, but then you see suddenly the wind has become southwesterly, southerly, so you follow it. And then you say it is going round. And it is forming a closed circle. Okay? So isobar, which is closed, and where the winds are moving in anti-clockwise direction in the northern hemisphere. With the lowest pressure at the center, it is called low pressure area. So this is, you must have heard many times, Bay of Bengal, a cyclonic circulation has formed, but the circulation may be not at the surface, it is at the, maybe at 0.9 kilometers or 1.5 kilometer in the atmosphere. And then slowly you will see that it's at the surface, a low pressure area is formed. And then once this low pressure area strengthens, that means you have now two closed isobars. If you have single closed isobar with the lowest pressure in the center and wind moving in anti-clockwise direction, you call it low pressure. But you have the lowest pressure in the center with two closed isobars, one, then another one at an interval of 2 millibar or hectopascal. Then you call it well-marked low pressure area. You will hear this terminology now in the coming months as the circulations form in the Bay of Bengal. Then if you have three closed isobars at an interval of 2 hectopascal, then we call it depression. If you have 4 closed isobars, then we call it deep depression. And if you have more than 4 with a wind speed, surface wind speed of more than 32 knots per hour, what do you call it? Hello?
Cyclone.
Cyclone, excellent. That's called a cyclone. And similarly, if it could be severe cyclone, extremely severe cyclone, like that. So is it clear to everyone? What is the low pressure area? So,
Yes, sir.
Yes, sir.
pardon? Yes.
Yes, sir.
Okay. So now you know, for rain to happen, we knew, I explained to you right in the beginning how rain happens. So naturally, moisture is maximum at the surface level. By some mechanism, it has to go up. So what are the different mechanisms by which moisture can go up? Heating of the atmosphere, thermal, adiabatic. Second, we said convergence and uplifting. Thirdly, orography, mountains. And fourth, dynamic reason, that means this low pressure system. So because of these reasons, the moisture can go up, and then rest of the things we all know it. Okay, excellent. Now, and what is in high pressure? High pressure is where you draw the isobars, joining again, it's a line joining the equal area, but highest pressure is at the center, and winds are moving around a high in which direction?
Clockwise.
Clockwise, excellent. So they are moving clockwise with the lowest pressure at the center. So now again, my next question is, you have a low pressure area over a area and you have a high pressure area. So what kind of weather you expect in these two regions? If moisture is
High,
coming. Yeah.
high pressure area with clear weather and the low pressure area with turbulence.
Turbulence, cloudy, rain, local. So excellent, excellent. Now, with this background, can you tell me which latitudes have the deserts in the world and why?
The high pressure zones. The high pressure zones.
Excellent. All high pressure areas, if you see your atlas, all the deserts of the world are around 30 degrees. That means 25, like 30 onwards. So that is a region, because that is a region where there is a subsidence. That means NT. For rain to happen, moisture should go up. Then there is moisture going up, cloud formation, condensation, cloud formation, rain, and then that's the thing. But where there is a subsidence, you have no cloud formation, clear skies, direct sun rays falling there. So those are the regions where you have desert conditions. So that means sitting here, if you know these mechanisms, you can predict the kind of soil in an area, the kind of vegetation in an area, what kind of agriculture people practice, what kind of dress they wear. Everything you can forecast sitting just in front of your computer or just knowing these mechanisms. Isn't it?
Yes, sir.
Do you agree?
Yes.
Yes, sir.
Okay, wonderful, wonderful, fantastic. Now, fine. Up till now, if there is any confusion, anybody want or have a question, please ask me. From there, I will start now moving towards how we do weather prediction and early warning. We will move to that. And how much time is left, please let me know that as well.
Sir, you have up to 1 p.m.
1 p.m.
A lot
1
of
p.m.
time.
Lot of time is there. Excellent, excellent, excellent. So we will take questions afterwards. Now, up till now, there is no confusion, isn't it? Fine, wonderful. So let us move now. So as I said, I have given you basics, and now we move to weather forecasting. I'm very lucky that I worked for India Meteorological Department, and my job was to watch the sky. Okay, where every day a new experiment is happening, right? And I'm paid for watching the atmosphere, understanding it, and then predicting it. So I love that, and it's excellent job observing nature, be in the nature, and getting paid for that. So I often tell people, like you have heard Spider-Man, Batman, I'm a weatherman. And that too, I'm an all-weather man. Fine. Now moving, no. So how do we do that? As I told, every day new experiment is happening. But how many of you observe the sky on daily basis? Do you? Or you don't? There's hardly. Do you have time for nature? Or most of you are busy on your computers or on your laptop or in your mobiles or in front of television?
No, sir.
You have time. Good. And one more advice to all is spend more time with nature. Watch how weather changes, how clouds form, beautiful rainbows. And clouds are also of different kinds. I'll come to that also. So there are different kinds of clouds, and each has its own, special characters and beautiful. It looks so beautiful. Especially if you see cirrocumulus clouds, they'll just look like fish scales. Then you have high cirrus clouds, which we call as mare tail clouds. घोड़ी के पूंछ की तरह दिखाई देते. So they're wonderful to watch. Cumulus clouds. They're just like cauliflower or cotton. They just look like that. Wonderful with a flat base, and like this. And when you have a lot of moisture and heat, they grow like towering cumulus, and ultimately they get converted into cumulonimbus. We will see all that mechanism. Okay. Now starting with that. So weather forecasting, first let me tell you that it is a very complex process, but it's not a rocket science. People with passion can definitely learn it. Okay. So how do we do that? So for predicting about future, first we must know what are the present conditions. How the temperature, pressure, humidity, radiation, etc. are there at the present moment. That means how different weather parameters are behaving right now. If in order to predict future, you must know the present situation. What is happening in the present? So what do you do that? For that, you establish a set of observatories to take observation. So we have a dense network of observatory distributed all over India. You name a city, you have now multiple number of observatories. Earlier, they used to be mainly manual, but now we have manual as well as automatic weather station. I think you must have also seen automatic weather station where we have a pole. On that pole, different sensors are placed, and they record that those sensors sense the temperature, and then through radio signals they give it to satellite, and from the satellite it comes to the ground station, and then ultimately it comes to your website, in IMD website, and where you can observe those things. So you have a very good network of observation. Remember, your data, this data is the backbone of weather forecasting. जैसे मकान का होता है ना, your house, you have a foundation. If foundation is strong, your house will be, building will be very strong. Similarly, if your data quality is good and it is very dense network, it is very good. It's again a backbone of weather forecasting. So the first and foremost important thing is to have a good quality, calibrated, and where from you will get good quality data? From good quality calibrated instruments. Many times what happens, you have an instrument, you install it, then you don't calibrate it. Over the time, it loses its accuracy. So on regular interval, India Meteorological Department sends its people with, they have the instrument which are calibrated, and then they go and they compare the instrument. If there is this thing, they find out the error, and that's how it is done. So on regular intervals, if you have an observatory in your region or your college or somewhere, so ensure that it is regularly calibrated. Otherwise, it may not give you good quality data. It is like if you go to market and buy Chinese thermometers, sometimes they are not of good quality. They give you erroneous readings. So you should have a good quality thermometer or whatever instruments like pressure. They all have to be regularly calibrated. Then only we will get the good quality data. So you get the data, which we call it data from the surface observatory, because these observatory, most of the parameters are recorded at 4.5 feet. But yes, wind is recorded at 10 meters height. But then you have logarithmic formula. You can derive wind speed at any of the heights. Okay. And again, there's a question here. What do you mean by when I say there is easterly wind? What does it mean? Hello? What do you mean? Easterly wind. Is anybody listening?
A wind coming from the western side to the eastern side.
No,
near the poles.
that is wrong. That is wrong. It's always the direction from which it is coming. Purvaya, easterly means it is coming from east and going towards the west, not west to east to west. So that's very important. Remember this. Okay? Very good. But only I think 1 or 2 people are answering. Why the others are not answering?
Sir, the postgraduate students are answering. They know some better knowledge about, they have some better knowledge about climate.
Okay.
And the undergraduate students are only at second semester. This is the first year from school. actually, the first year of higher education.
No problem. No
And
problem.
undergraduate
they are
students have-
shy to speak in English.
Okay, should I speak in Hindi?
Yes, they can speak in Hindi. And
Ah,
actually, the
so you should have told
undergraduate
me
students,
in the beginning itself.
undergraduate,
Arey, Beto, I can speak in Hindi, no problem, no problem.
the undergraduate students actually they are about to study climatology.
Wonderful,
They haven't
wonderful.
yet gone through climatology.
ओके 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 ठीक है तो मैं हिंदी में ज्यादा बात करूंगा मुझे पहले बोलते तो मैं हिंदी में ही बात करता
No, no, no. You can speak in English.
Okay.
They can ask you question or they can answer in Hindi. I
No
think
problem,
that will
no
be
problem,
better.
no problem. They should feel free and yes, बिल्कुल सही है, fine. So then now we were discussing so for weather forecasting के लिए क्या जरूरी है? We should have data from the surface observatory. But weather forecasting for we need to understand the three-dimensional structure of the atmosphere. So it's not enough that we should have data at the surface. I should also know what is happening at 0.5 kilometers, what is happening at 1 kilometer, what is happening at 3 kilometers, what is happening at 6 kilometers, what is happening at 9 kilometers. I should have data of all these levels in the atmosphere. Surface में तो it is very easy to measure the temperature, pressure, humidity, wind, etc. How do you measure temperature, pressure, humidity at 3 kilometer, 6 kilometer? कैसे पता लगाएंगे आप कैसे मेजर करेंगे टेम्परेचर को ह्यूमिडिटी को विंड को 6 किलोमीटर 3 किलोमीटर कैन समबडी टेल कोई बता सकता है
Last year, we had an exposure of radio sonde, the balloon technology.
Wonderful, wonderful. Yes, बिल्कुल सही है. Radio sonde. What we do is that we have India Meteorological Department has special balloons, and they also have different colors, pink, white, etc. So we use them under different cloud conditions. So ये बड़े-बड़े balloon में we fill it with hydrogen gas. Okay, and you know hydrogen is the lightest gas, and then what we do is that there are two ways. One is that we just release the balloon and track it with theodolite. Theodolite is an instrument, again, geography students must be coming across it for this thing. And then we track with this, we just come to know about the wind speed and direction. But what there is radio sound is, the other one is pilot balloon. So radio sound is what? You fill the balloon with that hydrogen gas and along with that you attach the instruments to measure pressure, temperature, humidity, all these sensors are attached and then the balloon is released twice a day at about maybe 100 locations or less than 100 locations all over India. And all these instruments go along with the balloon up and as they go up at each level, they relay through radio signals the data, temperature, pressure, humidity, etc. And all these are plotted on upper air charts. Surface data is plotted on surface charts, upper air data is plotted on upper air charts. Wonderful. And as the balloon reaches certain height, when the atmosphere is rare, naturally it explodes and then instruments fall somewhere. If they are good enough, when they fall back, our India Met Department address is written there, so somebody can return it to the nearest railway station and police station, and they send it back to us. If it is not damaged, we reuse them. Otherwise, get damaged. So you can imagine कितना पैसा इसमें जाता है कि instruments are very expensive. And daily, from 100 locations, twice you are releasing these balloons along with the instrument just to collect the data. Okay. Now, as I said, the first and the foremost thing in the weather forecasting is collection and observation. So observation means you observe, collect the data and observe the clouds also. Sky में कितना cloud है. So you report the clouds in octas. You must have heard the term octa. Octa means, that means when you look above, you don't have to see horizontally, you have to look above and above this, the sky is divided into 8 parts. So all the 8 parts are covered by the clouds. We say 8 octa cloud or overcast sky. That means sky में पूरे बादल छाए हुए हैं. If you have something like 3 octa, then you say partly cloudy sky. If there are 5 to 6 octa clouds in the sky, you say generally cloudy sky. If there are no cloud, you say clear sky. If there are 1 or 2 octa little clouds, then you say mainly clear sky. So these are the terminologies: clear sky, mainly clear sky, partly cloudy sky, generally cloudy sky, and overcast sky. So each has a different meaning. Remember this, depending on the amount of clouds in the sky. Is it clear to everyone? So these are all observations. So all these observations are collected. Cloud we are doing manually. Rest जो बाकी सब है वो हम लोग कैसे करते हैं? Through automatic weather station, or even manually. Temperature, humidity can also be measured. Relative humidity, you might be knowing. What we do is that there are 4 thermometers kept in a Stevenson screen. Stevenson screen is a wooden structure which has louvered this thing. That means there are gaps where air circulation can take place. It should not be a closed chamber, because otherwise it will record the temperature of a closed air. So there should be circulation. And direct sun rays should not fall on the thermometers, because we are not measuring the temperature of the sun rays, we are measuring the temperature of the air. That you should remember. Okay? And then maximum and minimum thermometers are kept horizontally, and dry and wet bulb thermometers are kept vertically. So this dry thermometer and wet thermometer are similar thermometers, but only difference is that this wet thermometer, what we do is we cover the bulb of the thermometer with a muslin cloth and a thread, and this thread goes into a bottle which is filled with water. So due to capillary action, the water goes up, it wets the cloth, and due to heat, the water evaporates, and when water evaporates, there is cooling. So similar thermometer, but this thermometer, because of evaporational cooling, records lower temperature than the dry bulb. So wet bulb thermometer, dry bulb thermometer. And you have a ready reckoner. That's means a table. One side it's dry bulb temperature written, and another side is wet bulb. So whatever you record on a particular case, you see dry bulb is 20 and this is maybe 22. Then you go and the place where they meet, that is your relative humidity. That's how it is calculated. It is easy. Tables are available depending on the your altitude of your station. Remember, all observatory will not have the same table. Depending, some observatory may be at the, say, Calcutta may be at just around sea level, but there are certain stages like Darjeeling, which may be at a height of 1800 meters or like that, or 1500 meters. It will have a different hygrometric tables. So remember this also. Many times people make mistakes. They use the same hygrometric table for all the observatory, then they will create problem. That will be wrong reading. Wonderful. Similarly, you measure rainfall. You have a, container. Inside there is a, measuring cylinder capped, and it has a surface area of 200 square centimeter. Whatever rain. Remember, for measuring rain, you should follow the IMD or WMO guidelines. The rain gauge should have a surface area of 200 square centimeter. And inside the cylinder which is kept is also of 200 square centimeter. And it's a glass cylinder. Many a times in observatory, what happens is the cylinder breaks and people go and buy something from the market and then they start measuring it. Either it could be 100 square centimeter or 400 square centimeter. It will give erroneous readings and it will lead to climate change. It might report the double rainfall. If it is 6, it will report 12 centimeters. So remember, these things are very important. Whenever you go and see an observatory, you must see in the rain gauge that cylinder, what is its capacity. 200 square centimeter cylinder should be there. So these are basic things one should remember. So all this data from the surface area plotted on the surface charts, data from the upper air data, which is collected through radio sound, is plotted in different charts. And once you plot these charts, earlier we were doing plotting manually, which used to take hours together. We're leaving less time for interpretation and forecasting. But now we have softwares. Automatically, when the data from the automatic weather station is collected, it goes to the satellite, to the Earth station, and from there it is transmitted all over the world. Like data collected at Alipur, Kolkata, immediately it goes to our Pune, Delhi office, Mumbai data, Delhi data, everything. And then from there it goes to Tokyo, Canberra, New York, because we have a tie-up under WMO. So that's how. And remember, for predicting weather of Kolkata or West Bengal, you need data of the nearby, from the same state as well as nearby states and the nearby countries. Atmosphere has no boundaries. So you need to have the global data. And remember, billions of bytes of data you have. Now all that data has to be analyzed. You can't do it manually, very difficult, and you can't do it on your PC. Maybe now in future we'll have very high computing power PCs, maybe. But then nowadays we have supercomputers. So all that data goes into the supercomputer where there is a software, and that software, through that it is plotted. And once that data is plotted, what is the next stage? Observation, plotting. What is the next stage? Analysis. Data is analyzed. When I say analysis, it means basically you're drawing the iso bars so that you know why we draw isobars, to find out what.
Similar.
Pressure zone.
Pressure.
Yes, absolutely. Where is there is a low pressure? Where is those pressure? Who answered this?
Pritam Nath.
Pritam.
Yes, sir.
Pritam Nath, I think you can become a weatherman. Wonderful. Very good. Excellent. So analysis means you have drawn the isobars. Now you know where the winds are rotating, whether it's in clockwise direction or anti-clockwise direction. So you identify low pressure and high pressure on the charts. And you are also following the winds because isobars are following the winds. So you know whether winds are coming from the ocean or they are coming from inland, dry. So naturally, if they are, suppose it's West Bengal, they are coming from Bihar and other area, UP areas, which is dry area. So naturally, moisture is not there. But if, yes, winds are easterly, they are coming from Bay of Bengal, Bengal की खाड़ी से आ रही है हवा, so वो अपने साथ नमी लेके आएंगी, moisture लेके आएंगी. And you have a low pressure area in your area. So what else you want? Moisture आ गया. There is a mechanism to lift it. Cloud formation and rain. Now question comes is, how much rain? That's what the thing is. So observation, plotting, analysis, and then you draw inference out of it. And then you forecast. Okay, now when you forecast, you say, okay, rain is going to happen. But then if you write that thing in your register and on your computer, but you don't disseminate to people who are planners, people who are common people or farmer or somebody who's on a ship or going in an aeroplane, if you don't share it with them, it's of no use. So all this forecast which you generate has to be disseminated on real-time basis. Weather forecast when data has no shelf life. That means you keep it for 2 days and then release it, it's of no use. It has to be transmitted on real-time basis. Immediate. So dissemination. And dissemination means you disseminate through television, radio, newspaper, social media these days, WhatsApp group. I mean, you name the thing, we do that. Fax, everything, email. Through all mechanism, we try to disseminate that in forecast to users, various users. It could be anybody. Okay. So up till now, any confusion or anything not understood? Or I can move further? I can move. Okay. So this is how weather forecasting done in a simple way I am explaining to you. Fine. Now, question comes, why do we do weather forecasting? Can anybody answer? Do you need really weather forecast?
Yes, sir.
Why?
Yes, sir.
Why do you need weather forecast? क्यों चाहिए
To
आपको?
prevent future risk. To prevent future risk and for the betterment of the society.
ठीक है, better the society in how?
Avoid hazard by weather forecasting.
See, not avoid hazard. Okay, ठीक है. बोलिए, hazard one, wonderful. Yes, next. Very good. Hazard हो गया.
To plan properly for future.
Plan what?
Plan what to do, how to
Plan
farm,
how to farm.
how to choose the crop.
Crop. Very good. Very good. Very good. Next.
Saving lives
To
and
prevent,
reduce disaster risk.
Disaster. Prevent disaster. Okay. Next. Very good.
Prevent economic loss.
Prevent economic loss. Yes.
Yes.
Yes. Very good. Very good. What else?
Mitigate all economic damages or
Okay.
losses.
Okay. That's happened. I mean, what is new? Next.
Transport.
Yes. Transport. Very good. Very good. Transport. Whether on this thing on the surface or in the.
Environmental protection.
Yes. Yes. Very good. Transport. What about electricity generation?
Industry.
Hydro generation. What else?
Industries.
Industries also. Okay.
Military and defense.
Military and defense. Excellent. So basically, hardly there is any.
Tourism.
Pardon? Yes. Yes. क्या बोला अभी सुनाई नहीं दिया मुझे.
Tourism sector.
Huh?
Tourism sector.
Tourism.
In
Excellent.
tourism sector.
Tourism. Yes. Absolutely. Yes. Yes.
Environmental protection.
Environment protection. Yes. Yes. Very good. Very good. Very good. So that means there is hardly any area where weather information is not required. Say, for example, somebody said tourism. Now, if somebody wants to go to, say, Darjeeling and wants to see snowfall, and there is a weather forecast that snowfall is going to happen, naturally, all the people from West Bengal and nearby states will rush to Darjeeling, and all the hotel industry or hotels will be full, taxis will be full, restaurants will be full. So see how it is happening the economy. Similarly, if there is a heavy rain warning by the Met Department, there could be flash floods, there could be floods, there could be landslides. So you have to avoid at that time those areas. Similarly, you are going from, say, through ship in the ocean and there is a cyclone. So if the Met Department said you can take precautions, you can postpone your journey. So these are the things, weather tools. Similarly, you want to develop a dam somewhere. So what should be the size of the reservoir? Suppose you don't take into account the rainfall of the past 100 years in that area. Then either you may make a small reservoir and rainfall is high, the reservoir will break, dam failure. But maybe rainfall is less than you have built a big reservoir, it's of no use, unutilized capacity, it's a waste of money. So all this helps in your planning, right? Even construction of your house. Whether in your area, what is the maximum wind speed, what is the maximum rainfall in that, accordingly you will design your house. Wind speed. Planning a town. If suppose mainly you have the winds from say east and you have a town here and you have an industrial area here, what will happen? All the industrial pollution will come here. So you need to plan a town based on the meteorological data. That's very, very important. And as you hazards will always be there. 100 years ago also there were floods, droughts, cyclones. Now also they are there. In future also it will be there. Whether there's a global warming or climate change or no, the hazards are going to be there. But with proper weather forecasting and early warning, we can prevent a hazard from becoming a disaster. So I can assure you, with the kind of technology, the kind of knowledge, and better weather forecasting and early warning, we can prevent disasters. Hazards will be there. Cyclone will definitely form. It will come to your side. But if there is a proper warning, you evacuate people and you don't do illegal construction on the coastal belt. Then cyclone will come and go. But in fact, it will give you so much of water, your groundwater will recharge. Okay? And whatever floods also come, if you are not living near the river, no damage. You are away from it, flood will come and go and it will leave lots of nutrients. Your agriculture production will increase. So all these natural mechanisms may look hazards to you, but it has their own benefits. Remember this. So my job is to predict weather well in advance and disseminate that information to the masses, to the planners, so that timely action is taken. And if it's a bad weather, how to evacuate people, take action. So bad weather and good weather. If it's when it's bad weather, how to reduce the losses, and when it's a good weather, say rain is happening, so you harvest it. And whenever there is a less of rain for your crop, you utilize it. So you have a good weather code and you have a bad weather code. So you can do all that. So similarly, you have in the industries I have told pollution. Remember, pollution happens when the atmosphere is stable. Stable atmosphere and unstable atmosphere. These are two conditions, again, very, very important, you should know. When temperature decreases with height in the atmosphere, we call it atmosphere is unstable. That means under those conditions, cloud will form, rain will form. But when there is a subsistence or high pressure in or anticyclone, high pressure is also known as anticyclone. If anticyclone is sitting in your area, winds will come down. So that means if you release the pollutants, they will not disperse off, they will just collect there. So what we call that condition is capping of the atmosphere. That means winds are not able to go up and कम नहीं हो पाएगी, they will accumulate something like this. एक आपने एक मटका लिया, मटके में आग लगाया तो धुआं तो ऊपर निकल जाएगा, but if you put a ढक्कन on that cap, so what will happen? Smoke will remain inside. So similarly, under stable atmospheric conditions, you have capping of the atmosphere. Whatever pollutants you release, they just stay in the lower layer and pollution level rises. That's what happens, especially in the winters in northern India, especially in Delhi, NCR, and those regions. So you should know stable and unstable conditions. They're again dependent on weather. So we do give the weather forecast. Now you have anticyclonic conditions, and in few coming days, the pollution levels are going to rise. Stop producing, using your cars, or close down thermal power stations, close down factories, so that we can reduce the pollution to some extent. But it will not go unless until the conditions change. But yes, if a western disturbance moves, which is a low pressure area, it brings clouds, rain, and it clears the pollutants, it makes the atmosphere unstable. That's how it happens. So this is our job, to monitor the weather and climate, and it should be done 24/7. Remember, weather department, like doctors, hospital, weather department operates 24/7. Whether it is 26 January hoga, 15 August, or you Sunday, Saturday, we have to work. I used to work 24/7 for years together, because you have to maintain continuity. If you don't see the charts on daily basis, and again the charts are updated every 6 hours. So if you don't maintain the continuity, you will not be able to predict weather. So again, it's not that simple. You have to get involved, and it's a continuous, you have to keep watching it. If you maintain continuity, you know what has happened in the past, then it is easier to predict what is going to be happening in the future. So this is what that's how we do these things. Okay? So now coming back. So what else? Agriculture. Agriculture, see, the weather forecasting is very important. Farmers now are waiting, like in every state. The moment now IMD has said already it's in the Bay of Bengal, Andaman Nicobar, it has moved further up. Now, and in Kerala, it is going to hit this time. Normally, 30th June is the date of onset of monsoon, southwest monsoon in this India. But this time it's going to happen maybe 5 to 7 days in advance. And because conditions are very favorable in the Bay of Bengal, moisture is moving, and there are cyclonic circulation which have formed in the Bay of Bengal also, and the Arabian Sea also. Met Department is monitoring it, whether it will remain cyclonic circulations low or well-marked low or depression, or will it become a cyclone? So that we are monitoring those conditions, and that's how it happens. So now farmers are waiting. So the moment they know that the monsoon is going to reach their state, what will they? They will prepare the field, plowing. Then once the rain comes, after that, and there is enough soil moisture in the field, they will sow the crops. So that's how it's used. So it has very important role. And then again, your weather pattern of your region decides which crop to grow. Okay? cropping pattern. What should be the cropping pattern of your area? It should be based on your agroclimate. Because you have a high humidity and high rainfall region, so paddy is a good crop to grow there. But Punjab, which is semi-arid, very less rain, but still people grow paddy. Why? Because free electricity and free underground water, which is not a healthy practice, and that is the reason their groundwater is depleted. Some of the soils are so saturated, and the water goes up by capillary action. There is salt formation and saline soils. So this is against. So one should follow their cropping pattern according to the agroclimate. Then only it will be sustainable. Your seminar is sustainability. Why we are? All our practices are becoming bad because they are not sustainable practices. We are not following the actual agroclimate and climate-based agriculture. So we should know our agroclimate, and our cropping pattern should also be according to that. Not only that, when to irrigate, when to sow, when to irrigate, how much to irrigate, when to harvest.
No.
हेलो, तो ये सब चीजें आपको कब बुआई करना है, कब कटाई करना है, कब पानी लगाना है फसल को, कब पेस्टिसाइड छिड़कना है, कब बीमारी आएगा, when a pest will attack the plant, everything we can predict these days. So all these are very interesting and it can be done, and we are doing it in India Meteorological Department very beautifully. And now, is it clear to everyone at this moment? Any question?
No, sir.
Okay. So, weather forecasting in a simple manner, I have told you the thing. Now, next part is your early warning system. What do you mean by early warning system? Anybody has an idea?
Before any extreme weather condition,
Yes.
There is a prediction.
Correct, absolutely. That means before an event happens and before that, you give the warning about it. Suppose a cyclone is going to hit the Bay of Bengal or Kolkata and nearby regions or West Bengal. So if I tell you 3 days in advance that a cyclone is going to hit West Bengal coast, so what happens? You are prepared. So well informed is well prepared, or they said well informed is forearmed. So if you are prepared, then you can meet any eventuality, any hazard you can meet. So that is about early warning system. Okay. Now, many people think system, is it a machine? Is early warning system a machine? Or what exactly is it?
you have told
It is
about
a
so many
system.
steps.
Pardon? Yes?
You have told about so many steps from collection of data to analysis and
Correct.
convey.
Correct. So now, yeah, absolutely, very good. So early warning system basically has 4 components. Okay? It has 4 components. The first component is risk mapping or vulnerability mapping. That means, suppose you are living near the coast. So whenever a cyclone comes, water level goes how high in your region. So you have to do the mapping. Geographers are very good at that. You people can take your students and go to the coast, find out from the old data. Whenever a cyclone comes, water enters inland, how deep it goes in inland. So you can map it. Then how high it goes, that also you can map it. Then you can also find out which are the areas where the water is maybe 3 feet or 6 feet. That means people will be drowned. So what are the colonies or villages which will be drowned? So that mapping should be done. Which are maybe there is some villages where people are very old. They may be physically challenged, maybe blind or like that. So they are the ones to be, given help the first. So if you do the proper risk mapping, then that is the first part of your early warning system. This is coast. If it is a river, then flood, the same thing, flood. If it is near the forest, maybe forest fire. Right? If it's in Darjeeling, like that area, Kalimpong area, and those areas, then it could be landslides or flash flood. So depending on the hazard, you have to do risk mapping, which is the most landslide prone areas. If you are moving from West Bengal towards Darjeeling, and route, which are the areas which has the maximum potential of landslide in the rainy season. So if you know that, you mark that areas, that this is a landslide prone areas and there is a rain, then accordingly you can decision. So this is first part of the early warning system is risk mapping. Then second component of early warning system is your weather forecasting, which is done by India Meteorological Department, while risk mapping is done by the state government also, and where the tsunami is going to come or landslide, GSI does it, ISRO also does it. So mainly it's a job of state government. State government should do it because they know their land use, land cover pattern. It's a dynamic process. तो उनको देखना है कि कौन सी जगह पे और रेगुलर इंटरवल पे दे शुड रिवाइज देयर रिस्क मैप्स as per the changes, development activities, so-called development activities taking place in their region. तो आपने हो गया, risk mapping हो गया. India Meteorological Department is doing the weather forecasting. Although some private agencies also have started weather forecasting, but then that's I will say you should follow the government because there is accountability. Maybe they can also go wrong because weather prediction is weather prediction. Again, I'll tell you because we are trying to imitate nature. And it's difficult. Nature is very complex. Okay? So again, I will add here. Initially, when scientists wanted to predict weather, they thought observation of the atmosphere is enough because we are predicting rain or weather phenomena in the atmosphere. But then accuracy was not improving. Then they found out that the atmosphere means atmosphere. There is another sphere which is linked to the atmosphere. What is that sphere? Can anybody tell? Hello? To predict weather, you need data from the atmosphere. There is another sphere. These two spheres are interacting. Which is that sphere?
Hydrosphere.
Yes, excellent. Hydrosphere. Hydrosphere is your oceans. So when they found that they are interlinked, El Nino and all those phenomena. So they found that when we take ocean observations and merge these two, we develop a model, coupled model, accuracy improves. Then they realize, no, there is another sphere which we need to account for. What is that?
Biosphere.
Biosphere. How plants are this thing interact. Okay, that was also included. Then they said there is another sphere which is important. Yes.
Lithosphere.
Lithosphere, yes, soil, rocks. How albedo, radiation is reflected. So another sphere was added to it. Then they said one more sphere is left. What is that? Ice.
Biosphere?
Ice. North Pole, South Arctic, Antarctic, and Himalayas. Cryosphere. So you imagine these 5 spheres are interacting. And some areas you have observation, some areas you don't have direct observation. You get only through estimations through satellite sensors. So it's very difficult. So now imagine these 5 spheres interacting continuously and things are changing so fast and you need observations, then you need those observations, timely observations, quality observations, then you analyze it, plot it, analyze it, interpret it, and then issue the forecast. So it's not easy. So that's what I'm saying, it's complex. And because it's so complex and we are not able to imitate the entire nature model, what is our computer model is basically, it's a software. It's an imitation of nature, which is very complex. So we can go wrong. So like, for example, somebody goes to a doctor. Doctor will say, oh, this is flu season, you have a flu and maybe that's all. He will give you medicine. Or somebody will say, oh, you have this infection, take antibiotic, fine. The patient is okay. But sometimes what happens, the patient is going to doctor once, twice, thrice, and he is not getting better. In fact, health is deteriorating. Doctor will say, do this test, this test, ultrasound, X-ray, this test, that set. Still, he is not well. Then he goes to another doctor, another hospital, third, fourth, like this, and months together. And then one fine day, doctor says there is a cancer, third stage. Now you see, the patient is right in front of you. You have best of the technology available, and still they are not able to diagnose the disease. And here I am predicting weather of the, which is atmosphere, which is has no boundaries. Cyclone is coming from the South China Sea. Western disturbance is coming from Caspian Sea. So it's so complex. How do you do that? So I can also go wrong. This is what I'm trying to tell. So it will never be 100% accurate. It's not a pizza delivery. That's what people want it like that. So it's very, you should understand it's a complex, very difficult to predict. You should appreciate how we have improved the weather forecasting. Like, for example, 100 years back, cyclone used to come and kill lakhs of people in Bangladesh and West Bengal region. But now the mortality has come down to maybe single digit like that. So just see how much life is being saved. And can you, say how much of money is saved? You can't put a value to life. So if you save lives, and I'll tell you, I have saved my entire salary as my staff with my forecast. I saved thousands and thousands of lives. I have given farmers that do not irrigate as there is going to rain in the next 48 hours. So if there is 10 lakh hectare irrigated area and the cost of irrigation is 500 rupees for 1 hectare, can you imagine how much money I save just with one forecast? And this I have done 100 times. So I've already earned the salary. I've already given that much to the society by saving lives, saving irrigation, saving electricity, and then contributing directly to the economy. So we are not only contributing to the economy, and when I save irrigation, I save the groundwater. And suppose somebody has applied the pesticide and rain comes, the pesticide or fertilizer will go waste and it will go into the lake and it will pollute there. And the same will go to the fish and you will eat that fish, biomagnification, and again problems. So I'm saving life, I'm saving health, I'm saving environment, I'm contributing to the economy. See the importance of weather forecasting. If you put $1 as investment in weather forecasting, it is equivalent to something like maybe $20 or $15 as a return. So that's why we should invest more and more. That way we will contribute to our economy, save lives, and naturally one hazard which is not predicted and it destroys a particular state, your economy goes down by 10 to 15 years back. And all that money goes into relief measures. But if you predict and save life and evacuate people on time, whatever money it would have gone for relief, you put in building colleges, schools, and it contributes to economy and you grow. So that is why if you want to be a superpower in the future, you have to be good in weather forecasting. If you contribute to your economy is good, will be militarily good, and you will become a superpower. So it's a big role to play. So second component is predicting weather, and third is dissemination. As I told you, if I keep weather forecast on my table on my computer and I don't share it with the planners, with the users, common masses, it's of no use. So, and on real-time basis, before the event happens, it should reach them. That is the value. And this weather forecast also should have certain good attributes. कि उसमें क्या अच्छाइयाँ होना चाहिए. सबसे पहले it should be accurate, timely. सबसे पहला timely. It should reach before the event. It should be accurate. It should be location specific. It should be impact based. That means if there's heavy rain, what impact it will have? Flooding like this, strong winds, trees can fall, these hoardings can fall. So what is its impact? All that. And it should be actionable. That means planner should know what action to take when such a warning comes. So these are the good attributes of a good weather forecast. Timely, accurate, location specific, impact based, actionable. And sixthly, it should be in simple language, understandable. If I make it very complicated, then people will not be able to act on that. So local language, if it's in for West Bengal, it should be in Bangla. If I give in English, many people will not be able to understand it. So it should be in Bangla, which people can understand it. So after that, I have disseminated information. The fourth, what would be the fourth component? Can you guess? I told the early warning system has 4 components. First component was risk mapping. Second was monitoring and prediction of weather. Third was dissemination of information. What could be the fourth?
Sir, preparedness.
Preparedness is fine. Now we have to move to the next stage. What is next stage? What is the next stage?
Sir, response capabilities.
Response. Excellent. Response action. That means the authorities, the government authorities, the district magistrate, collector, they have to know, okay, in this my district, a cyclone is going to hit in the next 48 hours. What should I do? I should relocate the people, vulnerable people, as per the vulnerability risk mapping. That these are the people who are going to get drowned. They have to be put in the shelters. Shelter has to be constructed where medicine, food, water, all things are provided. They are shifted to those places. Cyclone will come, it will go back, and then people can return back to their areas. So response is very important. And remember, all these 4 components should work on the same wavelength. If one component is weak, your entire early warning system will be a failure. It will fail. Early warning without early communication has no meaning. If I don't communicate, it has no meaning. Early warning, early communication, but no response has no meaning. Again, it will fail. Now I will give you one example. 2013, there was a major disaster in the mountains. Do you have anybody has a knowledge about it? Where was it? When? What was it? 2013 June. Hello.
Sir, Kedarnath.
Farkaban.
Kedarnath. Excellent.
Farkaban.
No, not Farakaban. It's Kedarnath, June 2013, 16th and 17th of June. So now, was there, thousands of people died in that. Very heavy rains and flash floods. No cloud burst. I will come to that. So was there a warning by the Met Department? Hello? Was there a warning?
Burst of glacial lake. It was burst of glacial lake.
Oh, well, forget about that. But my question is, I mean, that government says, okay, but was there any warning about the heavy rains, very heavy rains, etc.?
Yes, rain
Yes, yeah.
was there.
Pardon? Was there a warning by the Met Department?
Yes, alert was there.
Alert was there.
Heavy rain.
Okay. See, I must tell you that I was the director of that state from 2002 to 2015. And I had told the government 3 to 4 days in advance, heavy to very heavy rains are going to be there. भारी से बहुत भारी वर्षा होगी केदारनाथ में. I had pinpointed Kedarnath. So timely, that means 3 days in advance, I told the government, क्या बोला? भारी से बहुत भारी वर्षा होगी, भूस्खलन, landslide is going to be there. Timely, accurate. Then I said landslide. That means I am saying the impact also. Then I said, if you are in the mountains, go back to the safer places, and if you are in the plains, do not go to the mountains. Advisory also was given to them. और सिंपल भाषा में उनको बताया, हिंदी में, भारी से बहुत भारी वर्षा होगी, भूस्खलन होगा 3 दिन पहले, और 4 धाम यात्रा, because Badrinath, Kedarnath, Yamunotri, Gangnotri, these are 4 holy places where people go. I said, postpone 4 धाम yatra by 3 to 4 days. Now you tell me, is there any weakness in my forecast? It has all the good attributes of a forecast. But still people died. Why? Why so many people lost their life?
They can't respond.
Pardon? Response was poor. State government did not help. They did not stop people. They did not put barriers. But
Governance was
government,
not-
yes, government failure. So that means, although they were announcing there, but at the very last moment, I had told them 3 to 4 days in advance. And then there were people who were, like ponies, खच्चर में लोग बैठ के जाते हैं. So those people went on strike. So now people were stuck there. And there were hardly any place where they could feel safe. So people who moved into the temple was the safest place. And many moved towards the forest. They lost their way, although they survived because of this. But then they went into the forest, they didn't have food, they didn't have water, they were so low temperature over there, they died. So that means there was no planning by the government. There was no alternate road. Road was totally destroyed. There were no shelters, no registration of these yatris, pilgrimage, the people who had come. There was no registration. Their vehicle was not registered. So how many vehicles were lost? How many people? This thing. Government said 5,800 people are missing, but actually more than 15 to 20,000 people lost their lives. And this when I had given warnings, and these warnings were on the front page of the newspaper 3 days in advance. Front page news was this. People who read that, or people who heard me on television, they called me, we want to go. I told them, you are not going there. So many people who did change their plan, their lives were saved. But many people who had left some 8 days on foot, naturally, they didn't had any access. Government had their mobile numbers, so they couldn't contact them. So it was failure on the part of the government. And one very important thing, because it's disaster management, sustainability. Now what happens? So huge number of shops and resorts and hotels were built inside the floodplain. They were all washed away. Wrong planning. How the sustainability will come when you are doing the wrong planning? You are not following the risk mapping. You are not following the nature. So no sustainability. But now when you go back, again the people are constructed in those areas. This is the fault here. How can system be sustainable? These are the issues. So what is important is that development should be such that it should prevent disaster. It should save you from disaster. But right now, what the kind of development we are following is, our development itself is becoming disaster for us. It is creating a problem for us. So this is what happens when your response is poor. So as I told you, many times it has happened, and there could be times when forecast is wrong, or we are not able to predict, especially when it is a mesoscale event. That means thunderstorm in this particular season. All of a sudden you have very high intensity rainfall. And let me tell you, Kedarnath was not a cloudburst because government was failed. So they blamed on Met Department, saying that they didn't have radar. So it was a cloudburst. That's why they could not predict. Let me tell you, radar is for predicting weather for 2 to 4 hours in advance. I had given them warnings 72 hours in advance. So you don't need radar for that. It was a well-defined weather system, a very strong western disturbance and a low pressure area which had formed in the Bay of Bengal, which moved from Bay of Bengal towards through your Bihar and like that, UP and to Rajasthan, and then western disturbance was coming from west to east. Both interacted. This being stronger, it tilted it towards the Himalayas, and this low pressure system hit the Himalayas at right angles, dumping all the moisture. So that's why very heavy rain happened in the Yamuna and Ganga catchments. So I had read the research paper. This research paper, I was trained in US and France on predicting early warning and heavy precipitation and early warning. So I could catch that. I had a conceptual model. I knew it's going to happen. I warned the government, but government did not take action. And not only that, after that, government implanted news in the different newspapers on one day in Hindu, one day in Times of India, one in Hindustan Times, saying Met Department did not give any warnings. So then people told me that, this is going against the Met Department. People will come and beat you because so many people have lost their relatives. In fact, one of the lawyer came to my office. He said, I will sue you in the court. You did not give the warning. I told my staff, throw this man out, and I told him we will meet in the court. Finally, the people went to the court, and it was a case in the National Green Tribunal. We were called. I replied and gave all the proofs because I had given all this through email. The time was there, date was there, and all these warnings were given to the Chief Secretary, Secretary Disaster Management, Director Disaster Management, District Magistrate, Superintendent of Police, and IG Intelligence. And it was there in the newspaper as well. So all those documents was verified, and court gave us a clean sheet. World Bank team came to verify our forecasts. They gave us a clean sheet, and they said state government did not respond. Oxfam, which has offices in 65 countries, they came and verified us. They gave us a clear sheet. Comptroller and Auditor General, their team came. They gave us a clean sheet. That means the first time in 150 years of IMD's history, the World Bank team came to verify our forecasts. Comptroller and Auditor General team came to verify our forecast. Oxfam, and all of them gave us clear sheet. And the government, and then I gave all this information, weather forecast, to BBC, and when it went on BBC, it went all over the world. Government came to the back foot and they started blaming it. They wrote to the central minister saying that Anand Sharma, who is the director of the Meteorological Center, is blaming the state government and transfer him. I was called at Delhi, and finally when I showed my forecast, they couldn't transfer me. And do you know what happened? Anybody of you know what happened afterwards? Can you guess? Who was removed? Hello? Hello?
You tell us, sir.
Huh?
You tell us, we don't know.
Chief Minister was removed. This is the turning point in the history of disaster management in India. A Chief Minister of a state was removed, who was after me. And not only that, HUDCO is an organization. They came and verified our forecast, and they gave me a prize of rupee 1 lakh for best early warning system. So this is the power of science. That means when the entire government was against me, everybody was against us. But I knew Met Department had done a good job, timely job, accurate job. Why should we be scared? Although many people threatened us, but we stayed there, and finally we came out winning. This is the power of science. So science for the society. That is what Met Department is doing. That is what Weather Department is doing. Science for the society. So we have to give the benefits of the science, not writing a research paper. That is what many people do it. Whatever discipline you are following, remember you have to contribute to the society. If you write a research paper or a book, copying here and copy paste, that's what most people are doing. I'm not saying all do it. Many people are doing this these days. And it's of no use. And result, when you find out nothing is coming out of it. Either you should be very creative, very innovative. You write such a thing which, tomorrow gives you Nobel Prize. What Amartya Sen has done, or maybe one Rabindranath Tagore is done, but not like copying everything. Otherwise, do whatever you do, it should have an application to the society for making the society better, safer, so that our society is safe and there is a peace. And where there is a safety, there is a fear, no fear, and there is a peace, there is prosperity. So people, prosperity, planet, then there will be sustainability. Otherwise, there will be no sustainability. And all sustainable development goals which you are talking, 2030, already 2025, we haven't achieved even a single goal, 17 SDG goals. We have failed because we keep talking, conducting seminars, but no output. We have to show the result. So without results, without directly contributing society, it has no meaning. We will not achieve sustainability, let me tell you. And successive governments have failed to implement sustainable development goals. I don't know when will we achieve that, although I'm very optimistic person, but seeing the government conditions, I feel very bad that what kind of people are sitting who do not have an idea of saving the environment. If you don't save your environment, even humans are going to become extinct. And tomorrow, if you don't save your water bodies, you don't save your soil, you don't save your environment, don't blame it on global warming and climate change. Let me tell you very clearly. You are over-exploiting the things, you are polluting the environments, all our rivers are polluted. You can't directly drink water from that. Soil is polluted, full of chemicals and fertilizers. How will you achieve sustainability? People are getting cancers, people are getting thyroid problem. All these are coming because of chemicals in your environment. So you have to provide clean, affordable water, clean air. Are we able to do that? Are our governments doing it? Please ask this question to your governments. Don't elect useless fools to the parliaments. Form pressure groups. Ask your MLA or MP, whoever comes to your area, what are you going to do for my environment? How are you going to improve my water body, my rivers, my forest? And let me tell you, why we are not saving our trees? Because we do not get, suppose the tree gives you signal for your mobile, you will plant trees. But what you are getting is oxygen. That is why you are not planting more trees. So I think I will stop here. And if you have any questions, please feel free to ask.
Sir,
Yes.
you said cryosphere. What is this cryosphere?
Cryosphere means Arctic, where all snow is there, Antarctic and Himalayas, full of snow. Those three, Himalayas is also known as third pole. So South Pole, North Pole, and third pole, Himalayas. These are full of ice, and ice or snow reflects the radiation, and that influences your. It's an important forcing. It influences your weather patterns. So that data is very, very important. Yes. Okay.
Okay, sir.
Anybody else? Any other question?
Industrial accident related to weather forecasting.
Pardon?
Industrial accident related to weather forecasting.
Industrial accidents.
Yeah.
No, you want to know that whether industrial accidents happen because of weather?
Yes, yes.
See, it can be because of weather also. Suppose you have a nuclear reactor on the coastal area, and a cyclone comes and it destroys it. So it could be industrial accident because of weather, but it could be due to human error also. Similarly, any extreme weather, if the industrial structure is not strong enough and it is storing some toxic chemicals, if it breaks or it gets destroyed because of extreme weather, then it will be industrial accident because of weather events. But then many times like Chernobyl or maybe some other events have happened in the past, they were due to human errors or due to accidents, industrial accidents. Yes.
Okay.
Sir,
Yeah.
hello. Since
Yes.
they, since our students and ourselves are geographers,
Yes.
what what would be the role of the geographers?
Geographers.
Or
So,
yes,
geographers' role is fantastic. I mean, because they are the one who study the various aspects of our natural ecosystems, right? They read about weather, they read about crops, they read about mountains, they read about ocean currents. They read
I am
about all these
asking.
factors. Pardon?
I am asking about the forecasting.
Oh, forecasting. Look. See. What I am trying to say here is that see, in India especially, to become a weather forecaster in India Met Department, you should have a degree in science. That's first thing. So you cannot directly become. But yes,
Exactly.
you actually I don't have because I am not president. I can show you how we can identify this system on charts through my website. If we have time afterwards, I can show you again that also. So what basically I'm trying to tell people is that whatever I have discussed, you daily start observing where is low pressure forming, where is high pressure. So if you open IMD website right now, I will show them how a weather system develops and which direction it is moving and how much rain it can give. So you can start monitoring. We want to make all of you Mausam Mitra, weather friends. Okay, so that you yourself can interpret weather, but then you cannot become a weather forecaster immediately. That you have to do course. But in abroad, you go if you have an interest. You can go to US where even with a geographic degree you can enter into weather forecasting. But provided you have some background of physics and maths, but you can always take those courses later on in the university and you can pursue that. But India right now we have a problem. Like they don't allow you to take courses in your university. You have a social sciences, you cannot go to environmental science. So environmental science people cannot, maybe physics cannot go to social science. But some universities do have this kind of cross-cutting sharing of courses. So that should be allowed. Yes.
Thank you so much, sir.
So, I mean, if time is, I think, still there, if you can open the mosam.imd.gov.in website, I can direct you from here and I can show them how satellite, radar, and wind patterns are there. Whatever I told you, you can see it over there. Is it possible?
Yes, sir, I'm trying. More from
But
dot.
then try to, I mean, if you invite me sometime in Kolkata, if you have 3, 4 colleges and schools, then I can come on my own and I can deliver and show them the right how we do it. And it's not, I'm telling rocket science. You can all understand. And I want all of you to be weather wise and climate smart so that you can make use of good weather and avoid bad weather. Yeah, wonderful. So I think, yeah, you can first click on the satellite picture.
Pardon, sir?
Satellite picture, it's written satellite. You press on that. Satellite picture is a down. No, not here, there. Here in the center. Center. You see satellite picture. No, come down. Yes. This is a satellite picture. Click on this. Yes. Now you see this is a current satellite picture. You can little enlarge it and you see the cloud mass moving towards the Kerala and in the Bay of Bengal and sea in the Arabian Sea. Both sides you have lots of clouds. So a lot of rain is happening right now in Karnataka, Bangalore and this Kerala region. Right? And if you see in the top, you have this thing again, this thing Jammu Kashmir also, top. So you have to, and then Gujarat and Maharashtra. Now you have to monitor. Gujarat, Maharashtra is the region 2 days. Heavy to very heavy rain can happen in this region. And people have to be very, very careful in these regions. Okay? So this very dense cloud mass you are seeing over Gujarat and Maharashtra region. So this is what so this is the satellite is give you synoptic view. It's an eye in the sky. So next what you can do is if you come out of this and then there is a next to it you will see lightning. Remove this satellite thing. Now there is a written here lightning. Next to satellite there is written lightning. No, no, no. Lightning. Here it is lightning. No, not up, up. Just a minute. Just a minute. Where you click the satellite, next to it is lightning. Yes, absolutely. Now enlarge this. Now you can see all of it. Just little enlargement. This is the current picture in India where all lightning is happening. Even you see your region. Just see. This is a region, northeast region. How many places right now thunderstorm is happening, rain is happening, thunder is happening, lightning is happening. So if you see daily basis these charts, if there is thunder and lightning in your region, you should avoid going outside because it lasts for 1 hour generally. And if you are outside, caught outside, go to a building, go to a mall. And if you are inside the car, stay there, don't move out, don't stand near the building, don't stand under a tree. That is most dangerous. So again, it's very useful. It's available to everyone. You can all see on your mobile phone, on your laptops. And that's what I'm saying. Become a weather mitra, Mausam mitra. And I want all of you to follow this pursuing weather. Okay, now come out of this. Now what you do is there is a thing written radar. Press that. Come down. Little come down. Just down. Let me here in this picture itself. Little come down. No, no, no. Come down. Come down. Come down. Come down. Come down. No, no, no. Down below there is a map. Again map. Down. No, not this. Come out of this and little below.
Correct.
Down below there is behind this there is another picture of radar. Not this.
এই ম্যাপটা না, এটা থেকে অন্যটা।
Can you see behind this there is another picture?
এর পিছনে যে ম্যাপটা।
Yeah, this one. No, there is again. Just go there. There are different radars are available there. Click on the radar. No. What are you doing? Move the cursor down. Not this picture. You will see another map where it. No, not this one. 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 Radar. You click on this picture on the west coast. West coast, Mumbai. You click near the Mumbai. No. See, another map is there which has all the radars being displayed. Come below. Press on the radar twice. Yes. Now you just follow this. Go down. Yeah, go down. Now here you have Mumbai. Click on that. No, not here. Mumbai. Click Mumbai. Yes. Click on this. Double click on this Mumbai.
কেন আমাদের কিছু করে না, আমাদের সারাক্ষণ দেখাচ্ছে আমাদের না ম্যাম কম্পিউটার একটা জিনিস দেখানো।
Click on that, radar will open and it will show the areas where you have the maximum rain is happening. You can monitor that. You click on the Mumbai. Click on Mumbai. Double click. Yes, very good. Now you see here, click on the first picture, left side first picture, click on that. Now you see this you see here, there is a scale. It shows the height of the clouds. So clouds may be reaching even 15 kilometers. So wherever 15 kilometers and color is yellowish and reddish, that means very strong rainfall is going to happen in those areas. Anybody can monitor from this radar. So whenever you have Kolkata radar, similarly in your region, if there is anything happening, you want to know it is going to be heavy, very heavy, which direction the clouds are moving, everything you can observe from here. Because I am staying outside, if I am physically present, I can teach you very small things which everybody can learn and utilize it for yourself. And then if you are stuck, you want to know more, you can contact the weather department, you can visit them and talk to them more in detail. Is it okay? Now you close this. Come out of it. Now what do you do? Come out of it. Come out of it. Go to the home page. Now you go down, go down, go down, go down, 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 down. Now here over here, left side is written. Forecast, left side. First column. You press on this. No, not this. This one, first one, first one. Press this. Now open. You put here view all times. It is written view all times. No. Don't go to up. Yeah. Just a minute. Just display this chart. Yes, slowly. Yes, slow. Up, slowly. Little towards left. Make it little left. Move this chart to the little left so that you see the entire India. Okay. Now you see. Yeah, just a minute. Over here, if you enlarge it, right? If you enlarge it. Now, can you see over Mumbai? Just see over Mumbai. What kind of wind pattern is this? Just see this. In which direction winds are moving? Can somebody answer this question? These are winds. Anti-clockwise. Just see, it is anti-clockwise. It is anti-clockwise. That is what I told you. When winds are moving anti-clockwise, they tend to go up. You have lots of moisture coming from the ocean, and this circulation is taking it up. It will lead to heavy rains. So entire this area is going to get very heavy rains in the coming days. So this is again thing. So similarly, if you go to the east side, you go towards the east. Put the cursor here. Now you see what is the wind direction. Here, see the wind direction. Wind direction is from south. You see southerly winds going like this towards the northeast. That means moisture is going from the ocean towards the northeast region, and you have over there orography. So again, there are chances of rains in these regions. So this is how you identify these regions. Okay? So entire chart you have to see where you have southerly winds, where you have anti-clockwise direction, circulation. Those are the areas you have to follow. So this is nothing rocket science. This is what I'm trying. It is easy. But it requires continuity. And not only that, this chart, if you see, come to the date, it has a date and time. Can you see that? Yes. And it says 850 hectopascal. 850 hectopascal means 850 millibar. That means 1.5 kilometer above the ground. This is a wind pattern at 1.5 kilometers. Suppose you want to know what is happening at, just a minute. Can you click on the, I told you, view all times. There was a column, view all times. Go up. Go up. No, not this, up. And this is different dates. Different dates charts are available. But you have to put there, view all times. Not this. Go to the top. Top. Here it is written view all times in green. Click on that. View all times. Put cursor in view all times. Now this displays you forecast for next 10 days. And now here it's written model charts. Click there. There is a cursor. Click here. Not here. Model charts. No, not this. 00 UTC, GFS, and here. Yes, click this. Click this. Yes. Now you click here. 800 Pascal plus rainfall. Next. Up. This one. Submit. So click on this. Click on this. Now you have charts. You have not clicked. Click it on this. No, you have that has changed. Model charts have changed. Again, you have to go back. Yeah, click and then again come to this. Then submit. And now see the charts. Yes. Now it is showing you the rain. Go to the right side, there is a bar. Go to the right side, there is a bar. Go, extreme right. Extreme right. Go to the extreme. No, extreme right. Your right. This side. There is a bar. Can you see the bar? Yeah, you saw that. Yes, this one. This is the measurement. If it is in yellow color, that means a light rain. If it is green color, it is moderate rain. If it is dark blue color, it means 70 to 130 millimeters of rain, heavy rain. If it is 130 to 200, it is very heavy rain. And then red color, extremely heavy rain. So now you see these are the region, coastal belts, you are getting maybe moderate to heavy rain. Northeast, maybe little bit area, otherwise rest of the areas is having light rain. So if you go to the next day, down below the chart, that will be chart for the next day. Yeah, yes, day 2. Correct. Go day 3. Yeah, just see red color is appearing. Some area you get heavy rain. Next day, yeah, just see red color. That means this coastal belt again, because there is circulation and there are high clouds, so heavy rain is going to happen in Karnataka and Kerala region. So this is how you yourself can observe all these things. So there is so much to be shown in this website. Again, northeast, you see, some circulation is forming here. So that's again, one needs to monitor this thing and your region. So I think I will stop here, but sometime I will come physically to your place and I'll teach you many more things there inside, which anybody can learn, and all geography students, because you know climate, you know oceans, you know about forests, agriculture. So you will be able to understand all these things in a better manner, because geography is science which connects all these things. You see the holistic view, and then you also see how it impacts our economy. So it's all interlinked. So I'll stop here. Thank you. If any questions, still feel free to ask.
Students, you can ask question. Thank you, sir. Thank you for a very enlightening session. I think students have been, or also ourselves, are very much benefited from your lecture. Students?
Yeah, Mani Kuntala is saying it's very, I don't know, I just couldn't read it. He said very insightful and interesting lecture. Very good. I'm very happy. And I'm sure you have learned something new today. And you will continue to read this and apply this knowledge and also share it with others. And my target for the next 10 years is to reach every district, school and college, and sensitize the youngsters about these issues so that they know how to utilize weather and climate information for our safety, for our economic development, for sustainability. And definitely, I'm telling you, weather science has a major role in this. And it's high time our politicians, our bureaucrats, our population all understand this, and we need to sensitize people. That is what is my job as President of Indian Meteorological Society. I was also the Additional Director General of India Met Department. And one more thing I also want to add is that my films are there on National Geographic and Discovery Channel on Kedarnath. You can watch it on internet. And just last week, there is an article, if you put Anand Sharma, the New Indian Express, there is a beautiful article, How I Have Helped the Society. So you can just, if you have internet here itself, you can click on that. You will get that article. Everybody should read that.
Yes, sir. We have got.
I think you have got it. You already got it. Correct. So please, yeah, you show them how we can help the people, and there are many other ways we can help the people. Correct. Good. So, ma'am, you are the one who were in JNU?
No, it is Bollori Bagchi. Bollori di.
I was in JNU.
Okay. Very nice. I don't know. When I see your face, maybe I will be able to remember, because JNU was such a thing. I don't know. I was first in Satluj hostel, then in Kaveri.
Oh, I was in Ganga hostel.
Ganga was near to Satluj.
Satluj, yes.
Yes. Maybe the same dhaba.
Ganga Dhaba.
Ganga dhaba.
Yes.
We could have maybe met somewhere. I don't know. Maybe you can take my number and maybe we should be connected
Okay.
to this
Please,
day.
please, sir. Please, sir.
Great, wonderful, wonderful. So nice interacting with you. Thank you to your principal, to your ma'am, all of you for giving me this opportunity to share my knowledge. And we will stay connected in future as well. Thank you.
Sir, could you please tell me your contact number?
My contact number is 94 11 575800. I will repeat 94 11 575800.
9451 double
No, 9411
double one.
575800.
Okay.
Oh,
Okay,
yes.
sir. Thank you so much.
Please, Anand Sharma, please be in touch.
Okay.
Thank you.
Sir, we are overwhelmed. Your speaking style and interaction in a very, very lucid manner is very much student friendly. And we hope we will soon meet you physically.
No, that will be great because
Don't
there are
you
many
have a
more
plan?
things. Yeah.
Don't you have a plan to come to Kolkata or West Bengal?
No, what I'm saying is that you arrange 3, 4 schools because I will come on my own, not an issue. But only thing, if it is a 4, 5 schools, I can do lectures in those 4, 5 schools. Then it becomes economical for me to come there. Otherwise, my carbon footprint will increase and it will be not sustainable. So please arrange those lectures for 4, 5 places. I will come, and I'm telling you, there are many other things which I will share, and I want to motivate people, and definitely they'll be motivated to contribute to the society and be a good citizen.
Surely, sir, we will arrange such a meeting with you. Positively,
Thank
sir.
you.
We have many things to learn from you.
Thank you.
Simply, we are
Knowledge is for
mesmerized.
sharing. Knowledge is for
Overwhelmed.
sharing.
Thank you so much, sir.
So nice of you. So nice of you. I am also, thankful to all of you for giving me opportunity.
Thank you.
Good day. God bless all of you. Thank you.
Thank you. Lots of network issue. I am unable to speak anything.